diagram shows a cross-section of the human eye. Light from an object is refracted by the cornea and lens to form an image on the retina. The shape of the lens is altered by muscles in the eye to allow images of objects at different distances to be focused on the retina. The closest position at which people can see an object is called the near point. The eye may be modelled as a sphere with a single thin lens as shown. The distance from the centre of the lens to the retina is 2 centimetres. So we're told that this distance is 2 centimetres. So that is fixed. That is fixed. When the eye of a 10-year-old child is focused on an object that is at its near point, the focal length is 1.5 centimetres. Complete a ray diagram to show this on the to scale on the grid below to determine the distance to the near point for the child. So we've got this distance here is 2 centimetres. So I would use the scale. That 1 centimetre is actually equal to 0.5 centimetres to get to fill the diagram. So, in other words, my image is appearing here. So my lens is here, and the focal length is there. So this is the lens. It's a converging lens. This is the focal point. The focal length is 1.5. So that distance there is 1.5 centimetres, which is 3 squares on my box. So let's have an object, an image here, and let's draw the rays for this image and find out where the object occurs. So you've got a few different rays you can draw. So I'm going to draw this ray which goes parallel, then that passes through the focus on this side, like that. We've got another one which passes through the centre of the lens, like that. And another one which passes through the focus on this side and then comes out parallel. It's somewhere over here is my object. So this is remember one square, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 11.5 squares. 11.5 squares, which is 6.25 centimetres. Okay. So we have a distance to the near point of 6.25 centimetres. Okay. So calculate the magnification of this image. Well, we've got magnification is the object distance over the image distance. So that is 2.0 over 6.25. So we end up with a magnification of 0.32 as a magnification. So now, 4 marks. The distance of the near point from the eye increases as people get older. Because of this, older people use reading glasses to enable objects close to the near point to be seen clearly. A person wants to buy reading glasses so they can read text at exactly a distance of 27.5 centimetres from their eye. The minimum focal length of this person's eye is 1.93, and the distance from the centre of the lens to the retina is 2 centimetres. The power available of lenses are: show an appropriate lens needed for has a power of 2 diopters. You may ignore the distance between the lens and the glasses and your eye. So this is an important phrase because that means that we can just use that the total power of a lens is equal to the power 1 plus power 2. So we need the total power to have a P total is 1 over the total focal length. So we need to find the total focal length of this lens. 1 over f is 1 over u plus 1 over v. 1 over u, the image distance, they tell us, is 27.5, and 1 over over 2, 1 over the image distance. So we're going to do 1 over 27.5 plus 1 over 2. So the total power, so this is our this is our 1 over the focal length. So the focal length used to be 1.86 centimetres. So this is in centimetres, but we want to find the power, which has got to be in metres. So power is going to be 1 over 1.86 times 10 to the minus 2. 1 divided by the answer. So we need a total power of 53.6 diopters. Must be our total power. Now we've got power of the eye and the power of the glasses, whereas this is the total power that we need. The power of the eye we can get by using 1 over 1.93 times 10 to the minus 2. 1 divided by 1.93 times 1.93 times 10 to the minus 2. The eye is going to have a power of 51.8 diopters. So power of the glasses must equal power total minus power of the eye, which is 53.6 minus 51.8. 53.6 minus 51.8, which is 1.8 diopters. So a 2.0 diopter lens is most appropriate.